All right, let's get started today with a practice exercise. So take out your speed drill and review exercise booklets. Turn to page 6. We'll take a look at exercise 5. Something you should have talked about in 7th grade last year is, and we've kind of been talking about this already, is this idea of getting paid, right? And I've mentioned a couple times when we've talked about being paid hourly wages or salary and tips and all that stuff, and I said, but we know you don't actually get all that money. Who takes a big piece of the pie? Uncle Sam takes his unfair share, doesn't he? And there's all kinds of different taxes. If you're looking here at exercise 5, a couple terms you need to know. First term is the term gross pay. Gross pay. And it refers to the amount of money a person earns from his employer. This is the money that you rightfully deserve. It's called gross pay. But from every paycheck, taxes are deducted, including federal and state income tax, Medicare tax, and Social Security tax. Okay, so federal taxes, Uncle Sam wants some money. State taxes, Georgia or Alabama wants some money. Now, I grew up in Florida. Florida didn't take any of your paycheck. Florida's a great place to live. But Georgia takes a good piece of the pie. Alabama does as well. If you're unfortunate enough to live in New York and California, they take really big parts of the pie. But then there's also Medicare tax, okay? So that way when you're old and infirm, supposedly Medicare is going to be there to take care of you, but really you're paying for grandma and grandpa to get taken care of. And so some of that money comes out of your paycheck. Social Security, supposedly there will be retirement money set aside by the government for you. But we all know it's not going to be there. So really you're just paying for grandma and grandpa. And so these last two taxes are called Fica taxes. We're going to look at this more later in the school year as a result of the Federal Insurance Contributions Act. So gross pay is what you should be getting, but you don't get gross pay. You end up with what we call net pay, and that's what's left over after the government's taken everything they feel that they want. Okay? And of course, they get to vote on whether or not they get to take more of your money. And of course, they're usually going to say, yes, we should take more of your money. And so taxes go up. And of course, current administration really wants to raise taxes so that way they can fund everything else. Anyway, so the money you really deserve, class, is called gross pay. And the money you end up with when the government's done with you is called net pay. All right, at your seats, we've got a few problems practicing with gross pay and net pay. Take just a few minutes to work. When you're finished, put your pencil down and look this way so that I know that you are finished. I suppose that Kyla, Jaden, Evan, and Rocky, if you happen to finish before I mention the first person's name, you can let me know, but I'm not sending you candy. You have to be in the room to get candy. Sorry. Maybe you can ask your parents for candy if you beat them all. Hayden's finished. And did he get them all right? That's the question.
Yeah, that's the question.
The rest of them still working to see if they can get them all right, just in case he didn't. By the way, Jaden, pausing the video so that you can say that you beat Hayden doesn't count. I'm picking on you. You wouldn't do that. I know that.
Sure.
Lexi doesn't believe.
Lexi doesn't even know.
I know. But she's sarcastic, so she doesn't believe. Danielle's finished. Evan, no calculator. Cheater. Maybe they're trying to start one.
At first it sounded like gunshot, and I got scared.
Take about another minute or so to work on these, and then we'll go over them together. Evie's finished. Go and put your pencils down, even if you're not finished. Let's take a look at these together. And the first problem says, Brooke Adams gets paid $7.25 an hour by her employer. I'm not sure if that's minimum wage anymore or not, but whatever. She works 20.25 hours 1 week. How much was her gross pay? How much did she actually earn, Hayden?
$146.81.
Good. How many got $146.81? All right, how do we get that, Hayden?
Multiply $20.25. 20 hours. 20.25 times $7.25.
There we go, 20.25 hours times $7.25, and of course round off to the nearest whole dollar. All right, then it says Brooke had $42.39 withheld from her paycheck for taxes. Find her net pay. What'd you get for that one, Hayden?
$104.42.
Good, and straightforward. What did you do to get that?
146.81 minus 42.39.
Yeah, take the answer you got from the first one, minus $42.39. So she earned $146.81, but she only got $104.42. Gotta love the government. Then it says David Elmers earns a salary of $465 a week. From this, $48 is withheld for federal income tax, $61 is withheld for state income tax, and $35.57 is withheld for Fica taxes. That's the Social Security and Medicare. Find his net pay.
$320.43.
Got them all. $320.43 is correct. We just subtract all those things. Maybe add them all together first and then subtract, or just subtract them successively, whichever's easier for you. $320.43. Anyone else get all three answers right? All right, Lexi, good to go. All right. Anyone 2 out of 3? A couple of them? All right, any questions on gross pay and net pay? Any questions? All right, pass those forward if you would, please. Take your textbooks out. Turn to page 86. Pass those forward if you would, please. And open your textbooks to page 86. And yesterday we began talking about significant digits, and those of you who are in my study hall at the end of the day during physics got to see some of that going on again. Probably noticed it before, but I was, interrupted your study hall time to point it out. And we said that if a number is 1 through 9, if a digit is a 1 through 9, it's always going to be significant. Really, the only question is 0. Sometimes 0 is, sometimes 0 isn't. So what would make a 0 always significant? Evie?
Decimal.
Okay, if there's a decimal in the number, it will, well, not even that, not necessarily true. But a decimal can affect whether or not it's significant. What would a 0 always be significant?
If it's holding a place.
If it's holding a place because it's...
A placeholder.
Yeah.
In the middle.
In the middle of the number. There we go. If a 0's in the middle of a number, so there's some sort of other digit, a 1 through 9 before, and somewhere after it's another 1 through 9. If it's in the middle holding a place, it's always got to be significant. Now, there are other times, if the 0's not in the middle, it's obviously either in the front or at the back, right? So what if it's at the front? When would a 0 at the front be significant? Hayden?
Decimal.
Never. Trick question. Never. If it's at the front of the number, if it's before that first digit, it's never significant, okay? So would a 0 ever be significant if it's at the end of a number, Hayden? Trick question. Maybe it's significant. Glenn, help him. Yes, if there's a decimal. So if it's before the number, it don't ever count. All it is fill in space worthlessly. If it's in the middle, it's always significant. If it's at the end of the number, it will only be significant if there's a decimal somewhere in the number. Page 86 in your textbooks, I want you to do the homework section, 1 through 14. Should take you about a minute and a half, probably. Numbers 1 through 6, you can either put a check mark for yes or an X for no, or you can actually write out yes or no. You don't have to write out your explanation, just be ready with the explanation. And then for 7 through 14, how many significant digits or sig figs in each of those numbers? Take about a minute and a half to 2 minutes, and we'll take a look at those together. Good. Glenn's done. Hayden's done. Evie's done. Lexi's done.
I still started on the other part. Don't tell Mr. Tedeschi.
Okay. I won't tell him what he doesn't know. Learn him right. Need to know basis. You need to know. Michael's done. He was done a few minutes ago, but I was talking. Whispering, whatever. Aubrey's done. Everyone stare at Danielle. Oh, Danielle's done. I'm just picking on you. All right, number 1. Is that digit significant, yes or no, class?
Yes.
Yes, it's a regular number. Number 2, class?
No.
No, it's before the number begins. Number 3?
Yes. No.
No, there's not a decimal. It's at the end, but there's no decimal. So it looks like I just estimated 400-ish, right? Round off to the nearest 100. If I put a decimal there, it would be significant because it would mean no, like it's exactly 400. But no decimal, so not significant. Number 4, class.
Yes.
Yeah, it's in the middle of the number. Number 5.
Yes.
Yes, it's after the number ends seemingly, but there's a decimal in there to show that it is indeed significant. Number 6.
Yes.
Yes, it's in the middle. Now there's a whole bunch of zeros in the middle, but all of them are significant. So number 7, Evie, how many significant digits? 3. Number 8, Glenn. 2. Number 9, Aubrey.
2.
Lexi?
3.
3. Because there's a decimal, any zeros at the end of the number are significant, so both zeros after the 4 are significant because there's a decimal in the number. Back to you on number 10, Aubrey.
1.
1. They're before the 5, so the decimal doesn't affect anything. They're before the first digit. Number 11, Hayden.
4.
4. Those zeros are in the middle. They all count. Number 12, Michael. 3. The first 2 zeros don't count because they're before the number. The last 0 does count because there is a decimal in the number. Number 13, Danielle. 5. And number 14, class?
8.
8 digits. All of them significant. Any questions on significant digits? All right, we're going to move off of that because it's not quizzed or tested anyway. But it's good to know for future years. Wanted to take some time to mention that. Turn over to page 92 now, if you would. Page 92, and I want you to do numbers 1 through 10 at the top of the page. Page 92. Just some miscellaneous questions. Answer questions 1 through 10. Take just a few minutes to work on that, and then we'll go over it together. Just about another minute or so working on these, and then we'll go through them together. All right, for sake of time, pencils down. Let's take a look at these together. Number one, what conversion factor is used to convert from yards to feet? What did you have for this, Aubrey?
I don't get that one.
She's Lexi. Evie?
3.
Well, we use the number 3, but conversion factor, remember that's those ratios or those fractions we multiply by. If we have yards, to get rid of yards, I would multiply by
3 feet over 1.
Good, 3 feet over 1 yard. How many had that? 3 feet over 1 yard. Okay, questions on that? Okay, quick reminder what kind of conversion factor is. Number 2, when converting from milligrams to centigrams, which way does the decimal point move? Back to Aubrey.
Left.
To the left, very good. Number 3, how many quarts are in a gallon, class?
4.
4. Number 4, what are 2 factors in a number in scientific notation? This is kind of a weird way of asking this. What are the 2 parts of a scientific notation number? Well, first you got some decimal that has one number, 1 digit in front, and you got 10 to some power. That's really what they were asking. Anyway, how many figured out that's what they were asking for? Okay, yeah, when it says the 2 factors, to remember, we would write a number, for instance, like 7.32 times 10 to the 8th, for instance. It says, what are the 2 factors? Well, remember, factors are things that get multiplied. So the factors are some digit with decimals perhaps behind it, and then 10 to some power are the 2 factors, but it's kind of a weird question. Anyway, number 5, is that number written in correct scientific notation? Why or why not, Danielle?
No, because the decimal is not after the 4.
Right, the decimal needs to be after that first digit, right after the 4, so no, it is not in correct scientific notation. Number 6, not something we talked about. We're going to look at this here in just a few minutes, actually. I didn't notice this was in this mix. To add or subtract numbers written in scientific notation, what must be the same? Hayden looked it up.
The power.
The power of 10. So we're going to look at this in just a few minutes, but to add, I can add another number to this, like 2.14. As long as it's got the same power of 10, I'm going to be able to add them. We'll look at that in just a couple minutes. Number 7, what does the prefix centi mean, Michael? 100th, right? 1/100th. Number 8, what is the name for a ratio that expresses the relationship between 2 units? Glenn? Look back at question 1. The name for a ratio or a fraction that expresses the relationship between 2 units? I can't hear you. Yards to fill. Well, that's an example of one, Michael.
Dimensional analysis.
Well, dimensional analysis uses these, Lexi.
Confusion.
Confusion? That's what seems to be reigning in this room right now.
Conversion factor.
Conversion factor. There you go. Confusion factor. Maybe that's what we ought to call it. Conversion factor is the ratio that expresses the relationship between 2 units. See, number 9. What's the basic unit of mass in the metric system, Glenn? Meter is mass? Remember, mass is like, if I talked about your mass, if I said, Glenn is a young man of great mass. Well, number 1, that's a lie. But what would that be talking about? He's a fat lard, okay? He's huge, right? He weighs a lot. That's what mass talking about. You wouldn't measure that in meters unless you're measuring like your girth, in meters or something, which, again, he's not fat. For you two who don't know him, okay, he's not fat. And Jaden's laughing really hard right now, and so's Kyla. Evan and Rocky don't know him, but he's not fat, I promise, okay? I wouldn't make fun of him on YouTube if he were. We'd pick on a skinny kid. All right, so... Gram, there we go, gram, or if you're really like of great mass, then it would be kilograms, right? We would need to, thankfully, even if you're not of great mass, we probably still need kilograms because a gram is so small. It's about like a typical paper clip, maybe a couple of those would be a gram. It's nothingness, right? So a gram is very, very tiny. Number 10, what is 110 inches expressed as a mixed measure? Hayden?
9 feet 3 yards. 9 inches.
Evie?
9 feet 2 inches.
9 feet 2 inches is probably the best way to go here. There's a couple ways you could go, I suppose. You could divide out the 12, right? It goes in 9 times. That's 108, so it leaves you with 2 inches left over. So 9 feet, 2 inches. Or, I suppose, instead of dividing by 12, class, you might divide by
36.
36, and 110 divided by 36, that would go in 3 times. Still 108, right? So still 2 left over. That would be 3 yards. 2 inches if you wanted to go that route, but probably the 9 feet 2 inches is the most basic answer there. Questions on the 1 through 10, other than number 6, which we hadn't gotten to just yet, which I didn't notice that was in there. Questions on those? All right. I want you now to continue here by doing the odd problems 11 through 35. So pages 92 to 93, numbers 11 through 35, the odd numbered problems. Again, we are kind of doing some review here. We got an exam coming up in about a week, so we want to make sure we are good to go with some of this basic stuff. 11 through 35, the odd. Again, the exam does count as 2 test grades. So it weighs the same as the last 2 tests you've taken. So if you did not as well as you would have liked on the last 2 tests, a great exam can do a lot to balance that out. So work diligently as we head into exam week next week. As you're working, obviously, if you have a question, raise your hand. I'll come by and help you. Don't sit there confused or just skip something because you won't want to do that on the exam. So again, as we're getting ready for that, even now, ask questions if you need help. And just the odd numbered problems. Hayden's finished. Almost finished. Just a couple more minutes to work on these. Bless you. All right, for sake of time, pencils down, even if you're not finished with all of these. And let's take a look at these together. Number 11, 18 teaspoons is how many tablespoons, class? 6. I just said it by accident. Divide by 3, right? You're going from the smaller teaspoon to the larger tablespoon. Number 13, 28 kilometers. How many meters? Michael. 28,000 meters. Moving the decimal 3 places to go to the unit, remember. Not going to the M. We're not going all the way to the milk. That's milli. We're going to the unit, which is the meter. Number 15, 5 decades. How many months when we use dimensional analysis, Lexi?
600.
600. We go from decades to years, right? 10 years over the decade, and then 12 months over the year gives you 600 months. Number 17. When we add that up initially, what do we get for our answer, Michael? Number 17. Pay attention.
61 feet 12 inches.
61 feet 12 inches. But we know that 12 inches.
Is foot.
So our final answer? 62 feet, no inches needed to be left over. Number 19, we have to borrow from the minutes, bring that 1 minute over to 60 seconds so we can subtract Glenn. Well, we don't subtract Glenn, but anyway, go ahead. 41 minutes, 18 seconds. Now some people in the class, maybe we could. No, we're not. Anyway, 41 minutes, 18 seconds. They don't really hate you, Glenn. Well, maybe Lexi does, but anyway, number 21 on that happy note. Number 21, Aubrey, when we divided by 2, we got?
1 tablespoon and 16 teaspoons.
Not quite sure what you did there. So 30 divided by 2 is?
1.
I see what happened. Okay. So we got the 30 tablespoons and maybe 2 teaspoons. Divided by 2. 2 goes into 3 how many times?
1.
Once, with 1 left over. You forgot to bring down the 0. So 2 goes into 10. 5 times. We weren't done with the tablespoons yet. I think what you did was you brought that teaspoon over, maybe the 10 over as 30, instead of, we can still finish the division out. And it ends up coming out evenly. So there's actually no tablespoons to have to move over. We just go 2 into 2. 1 time and get the 1 teaspoon. Does that make sense? So 15 tablespoons, 1 teaspoon should have been our answer. Number 23, during a 4-person relay race, the times for the runners were 1 minute 10 seconds, 1 minute 17 seconds, 1 minute 5 seconds, and 1 minute 13 seconds. What was the relay team's total time for the race, Evie?
4 minutes 45 seconds.
Good, we added all together 4 minutes, 45 seconds, nothing to have to carry there, so it kind of worked out easily for us. Number 25, what is that number in scientific notation, Danielle?
1.2674 times 10.
Good, 1.2674 times 10 to the 4th. How about number 27, Lexi?
5.72 times 10 to the 2nd.
Good, 5.72 times 10 squared. Number 29, Hayden?
3.5 times 10 to the negative first.
Good, 3.5 times 10 to the negative first. It's a value less than 1, so it's going to have a negative exponent. Also, we're in a sense dividing by moving the decimal backwards, so we need the negative exponent to show we're multiplying by a reciprocal. Number 31. Number 31. What did you get on that? Turning it back into standard notation, Glenn. 570,000. How about number 33? What would that be, Aubrey? 81,000. And the number 35, what would we get for that answer, Evie? 0.0067. How many got all the ones you did correct? All right, anyone just miss one of the ones that you did? All right, just missed 2. Questions on any of these? Questions on any of these? All right, turn back in your textbooks if you would to page 86. Back to page 87, I was right the first time. Page 87. And let's talk about adding scientific notation numbers together. Adding or subtracting scientific notation. You see this statement in bold, put a star next to it at the top of page 87. When adding or subtracting numbers in scientific notation, the powers of 10 must be the same. When adding or subtracting numbers in scientific notation, the powers of 10 must be the same. So if they are, though, for instance, you look at example A, letter A there, you've got a 2.3 times 10 cubed, and you're adding a 5.9 times 10 cubed. Well, once the powers are the same, number one, you start by just adding the numbers together. 2.3, 5.9, well, 3 plus 9 class. 12, carry the 1 plus 2 plus 5. 8, don't forget to keep your decimal. And then you're going to keep the power of 10. We don't add and get a 10 to the 6th power. We keep a 10 cubed. So we have 2.3 times 10 cubed, 5.9 times 10 cubed gives 8.2 times 10 cubed. Do we see we keep the power of 10, just add up the numbers. Now, later on in high school, you're going to find out what to do if these do not match. But you're in 8th grade.
Okay.
They're already going to match. So it's going to be easy. They just already matched for you guys. It's going to be that easy. It's just add, keep it. Not trying to insult anyone's intelligence here, but you know that's all it is. Questions? Look at the next example. 6.7 times 10 to the negative 7th minus 1.8 times 10 to the negative 7th. You subtract, of course that involves borrowing and stuff, so you get 4.9, and you keep the times 10 to the negative 7th. Does that make sense? Any questions on those examples? Seem easy enough? Not blowing anyone's brain? How many recognize this as some stuff that was on the test that I had to cross off? Yeah, I probably could have figured it out, honestly, but you know, we hadn't talked about it yet, so I crossed it off. Your turn to show me that you could do this really easily. Turn the page. I want you to do numbers 1 through 11, the odd, at the bottom of page 88. Page 88, 1 through 11, the odd numbered problems. How to subtract the numbers? Keep that decimal point lined up, which it already is. Keep the same power of 10. Hayden's fast. Just sit tight and wait for just a little bit. Classmates shouldn't be far behind you. Glenn's done, Evie's done, Danielle's done, Michael's done, Lexi's done, Aubrey's done. Let's take a look at numbers 1 through 11. The odd. Number 1, what'd you get for your answer, Danielle?
9.1 times 10 to the third.
Good, 9.1 times 10 cubed. Number 3, what did you get, Lexi?
7.8 times 10 to the 16th.
It's 7.8 times 10 to the 16th. Number 5, when you subtracted, what did you get, Evie? 4.2 times 10 to the 4th. Number 7, Glenn. 2.18 times 10 to the 6th. Number 9, Hayden.
9.7 times 10 to the 11th.
9.7 times 10 to the
Negative
-11. And number 11, what'd you get for that one, Michael?
9.9 times 10 to the 0.
By the way, what is anything to the 0 power? 1. So 9.9 times 1, or you could just say 9.9, but they wanted you to leave it as you said it. 9.9 times 10 to the 0. And what do you got, 6 for 6? Okay, I'm going to insult your intelligence a little more by having you do the evens. Go back and do 2 through 12, the even. Yeah.
This is number 7 and I don't know why.
Missed number 7 and don't know why. All right, let me take a look at it with you real quick. So we borrow, right? Or we make this 0 and we borrow, make this an 8, make this a 1. 10 minus 2 is 8. 8 minus 7 is 1. 8 minus 1 is 2. 2.18 times 10 to the 6th. Is that not what we said? 2.18 times 10 to the 6th is what Glenn said. I think that was his problem. You got it right. You didn't miss it. Trying to avoid throwing anything super hard at you right before the exam, right? Let it be nice and easy. So if you're still working on memorizing those units, you can. If you're still working on memorizing those fraction decimal equivalents, you can. Take pity on yourself and your poor tired brain. You say, thank you, Mr. Dasky, and you bring gifts.
Sure.
Cash gifts are best.
It's 25
Gift cards are acceptable also. It's worth a try. Yeah. Even if you're watching on YouTube, I accept gifts through the mail. You know, mail them to the school in care of my name, and they'll get it to me. If the office doesn't find out there's money in there and open it and steal it first, you can't trust those people in the office. All right. There we go. PayPal. All right, number 2. What did you get for your answer, Aubrey? 5.3 times 10 to the negative 6. Number 4, Michael. 7.95 times 10 to the negative 1st. Hayden, number 6.
1.3 times 10 to the negative 11th.
1.3 times 10 to the negative 11th is correct. Number 8. What did you get, Glenn?
4.7.
Well, we don't, not 4.7. Oh.
4.7 times 10.
We could do 4.7 times 10 to the 5th. There we go. Just dodge it completely. Or 4.70. It's not an O. That's a letter. That's 0 is a numeral. Anyway, times 10 to the 5th. Number 10. What did you get for your answer, Lexi?
4.3 times 10 to the 2nd.
Good. Or 4.3 times 10
Squared.
squared. Works great. And number 12. What did you get for that? Oh boy. Evie?
1.1 times 10 to the negative 23rd.
Yeah, aren't you glad you didn't have to write that as a regular digit? Right? That'd be what, 22 zeros first? That's really awful. 1.1 times 10 to the negative 23rd is correct. All right, how many got went 6 for 6 that time? All right, so we still good to go on these? Take a look at number 13 and read this word problem for us, if you would, Aubrey.
When all forces applied to an object are in the same direction, the forces are added. The following forces are applied in the same direction on an object. 1.5 times 10 to the 5th newtons, 2.4 times 10 to the 5th
Newtons.
and 5.1 times 10 to the 5th newtons. What is the total force on the object?
All right, what do we need to do here, Aubrey? Add them all together, because that's what's the total force. So we add them all together. How much total force acts on this unnamed object from these unknown, unnamed forces? Don't even know what they are. They didn't take a lot of time to put any thought into that one. It's like there's this object, there's these forces, here's what happens. Like, couldn't be like the object is like Hayden, and like there's these 3 guys all running at him at the same time, and you tackle him or something. No, nothing like that. It's just this object and these forces.
That's probably why you spent so much time putting that packet together.
I know, I spent too much time trying to come up with cool stuff, and they're boring. All right. All right, so Hayden, how much total force acts on this unnamed, unknown object?
9.0 newtons times 10 to the 5th.
Well, we put the newtons at the end. So 9.0 times 10 to the 5th newtons. There we go. How many had 9.0 times 10 to the 5th newtons? Good. Any
Well,
questions?
You would have ripped my smiley face in half for not putting it in.
Number 14. We're putting the newtons in the wrong spot. All right, number 14. Read this one for us, Evie.
If one sound has the intensity of 2.3 times 10 to the negative 6 watts per square meter, and a second sound has an intensity of 6.5 times 10 to the negative 6
Watts per square meter.
what is the difference between the intensities of the two sounds?
All right, what do we have to do to solve this, Evie?
Subtract.
Subtract. And at your seats, go ahead and do so. They're introducing some science concepts too here. Newtons for force and watts per square meter for sound intensity. Awfully nice of them. Make you feel really smart. And what do we get for our answer, Evie?
4.2 times 10 to the negative 6 watts per meter squared.
There we go, 4.2 times 10 to the negative 6 watts per meter squared. How many have an answer for number 14? Any questions on this at all? All right, your homework for this evening. Homework for this evening is to do pages 92 to 93. Pages 92 to 93. Numbers 12 to 36 to even. Pages 92 to 93. Numbers 12 through 36 the even. All right, we'll take a look at that tomorrow and continue working with scientific notation.